Okay, I'm recording now. Okay, I just want you guys that are listening to us, I'm looking like a dork in front of the classroom just for you guys, right? And everyone in the classroom is like, yes, we know, Miss Benson. Okay, so we're going to go through 67 and 68, just any questions that you guys have. So we're going to start, there's a question on 67A, so let's check that one, okay? So 67A is KMnO4, and this is a really good one to go through because we're going to use potassium. What's MnO4? Permanganate. You're going to need to know MnO4 has a -2 charge. That's just one that you're going to need to know. Okay, so remember you're going to separate the cation and the anion. So we know potassium is +1. Why can we assign potassium right away? It only has a +1. What metal is that again? Alkali. Okay, alkali metal. And so if this whole thing is +1, then this has to be -1, right? Okay, I know that oxygen, I did say -2, didn't I? Yeah, it's -1. Okay, so I know that this is oxygen. This is -8. So what does manganese have to be? +7. +7, -8 is going to make -1 on that side. So last hour we were talking a lot about if it asks what is its oxidation state, it's really potassium is +1, manganese is +7, oxygen is -2. It's not asking for the -8. The oxidation state of oxygen is -2. Okay? All right, then there's a question on D, so let's look at that one. Okay, so again, separate this out. What do we know the charge on ammonium is? +1. Always +1, so this half is +2. So this half has to be -2 to balance that out. Then start inside. Between nitrogen and hydrogen, which one do you know? Hydrogen. Hydrogen's oxidation state is +1. I have 4 of them, so that's +4. What is nitrogen's oxidation state then? -3. Okay, Danny? It can in rare situations, but it's really rare, so I wouldn't worry about it. Always just say that's going to be +1. Okay? So yes, because of where it's at, it does want to gain 1, but more times than not, hydrogen's going to lose it. Okay. All right, so this is -3, and then over here, I know hydrogen's +1. I know oxygen is -2. So I have 4 oxygen, that's -8, plus the 1. So what is phosphorus going to be? +5, right? +5 plus 1 is +6. With the -8 is going to give me my -2. Okay? Any other ones on 67 or 68? D on 68. Oh, 68D says AS4. Natalia asked that earlier. And because it is just like this, there's not any charges around it, and I know it's a weird one with arsenic. That's how it naturally exists. So it's going to be 0. So if you look at it the same way as if it was just plain old copper, plain old aluminum, they're all going to be 0. Any other ones on that? Okay, so your quiz tomorrow is going to have 5 like this. You're going to be given 5 of them, and you just have to assign the oxidation states. And then you're going to have 3 of them like question 71 and 72. So we're going to tackle those today and make sure you got that. So on number 71, you guys were supposed to have assigned all of the charges. So if we read 71, it says, specify which of the following are oxidation reduction reactions and identify the oxidizing agent, the reducing agent, the substance being oxidized, and the substance being reduced. Okay, so we will jot down, I have that? Is it on the back, I think? They're falling off my head. Okay, so we have copper in the solid state. Okay, so we're going to start here with the charges. So if I have copper in the solid state, what charge did you have it as? 0. That's how it naturally exists. 2 with a +1 charge. Do I need to do anything with the silver ion? No. Then I have 2 silver in the solid state. What's its charge? 0. Good. And then I have copper. Does it have a charge there? +2. Okay. So it shows you in the book that it was +2, so you don't have to add anything to that. Okay, any questions with those charges? So now we have to show how it's changing. So take a look at the notes that I told you to pull out. Let's see, where are they? So this is right here. This is the information that's going to get us to be able to understand what's being reduced and what's being oxidized. Okay, so there's lots of terms here, but I think if we keep it really simple, you guys will understand it. So in the redox reactions, electrons are being transferred from the reducing agent to the oxidizing agent. It's always going to be reducing to the oxidizing. The reducing agent, the material is being oxidized. The oxidizing agent, the material is being reduced. Sounds like a lot's going on, right? Okay, so what we need to remember is this is going to be very, very important. Leo goes grr. Leo the lion goes grr, right? Okay, so Leo means, your book even has this. So this isn't crazy Miss Benson making this up, all right? Little Zumdahl book in there has it. All right, so Leo, loss of electrons, oxidation. Loss of electrons, oxidation. Grr, gaining electrons, reduction. Okay, now some of you have seen my lovely beast that I drive, my Expedition that's 11 years old, and I washed it this weekend and some rust came off of it. And so it's the materials being reduced, right? Okay, so if you think about rust is a really good oxidation example. You take that piece of metal, take my Expedition that has these chunks of rust coming off the bottom of on the door. I can't quite see them yet, but if you get in there, you can see it. The material's being reduced, right? There's not as much there. How that is happening is the electrons are going away. If they're going away, that is a loss of electrons, oxidation. And when it goes through oxidation, it's being reduced. Can you kind of think of it like a piece of metal? All right? Think of it nice, clean piece of metal. If it's being reduced, something that's not as big as it was before, how is that happening? Electrons are going away. That's oxidation. And then reduction is just going to be the opposite. Okay? So we really need to make sure that we understand Leo goes grr. And when we do our redox and acid and redox and base, you have to remember those two. So the material being oxidized is always going to become more positive as it moves from reactants to products. So material being oxidized is going to become more positive. The material being reduced is going to become more negative. So keep that out, look at that while we analyze the questions that I assigned to you for today. Okay, so here's 71A. So what I want you guys, until you get used to it, I think it's nice if you bracket these. And when we do redox reactions, they're half reactions. You need to know these little combinations anyway. Yes, Danny. Okay, but this is the material being reduced becomes more negative because reduction means that they are gaining electrons. Electrons are negative. No, because then that's the oxidizing agent. Here, when they lose electrons, they're becoming oxidized. They're being reduced. That's the reducing agent. So your piece of metal is reducing down in size. How did it happen? It lost electrons. Okay? All right, so if we go back to here, I want you guys to bracket the things that are changing. You'll see in some other ones when we have more elements, it'll make sense what I'm saying, because here I just have one element at each. But when we get complicated equations, I want you just to bracket the elements that are changing. So what I mean by that, would you agree that copper is changing from 0 to +2? Okay, I bracket that. Silver is going from +1 to 0. Okay, so think about what this means. If I have something going from 0 to +2, is that losing or gaining electrons? Losing. Okay, so here's Leo. Leo goes grrr. Okay, loss of electrons, oxidation. So copper you just said is losing. So this is my oxidation half. Okay, check the other one to make sure you understand both sides, because there'll be some questions, some equations, you'll be like, I think that's the oxidation half, but you can verify it by looking at the reduction half. So here's going from +2 to 0. Is that losing or gaining electrons? +2 to 0. It's gaining, right? Because you got to gain that negative to get it back to 0. So gaining electrons, reduction. So is everybody okay with those halves? All right, so if this is my oxidation, then what is this copper? This is my reducing agent. And the silver is going to be my oxidizing agent. Okay? So in order to be redox, do we have to have charges changing? Right? Okay, so let's take a look at 71B. Take a look at the charges that you assigned. Is anything changing? Is hydrogen on the left +1, hydrogen on the right +1? Is chlorine -1 on the left and chlorine -1 on the right? Okay, how about nitrogen? -3 on the left, -3 on the right. So is B a redox equation? No, it doesn't mean it doesn't happen. We can take hydrochloric acid and add ammonia. We get ammonium chloride, but it's not redox. Nothing's changing. The charges aren't changing. Okay? How about C? Do you have the charges all written out on these? Or do we need to do that? Maybe a couple? Okay, let's try C. I'll show you why it's not changing. Okay, so C. I say solid, solid. Oh my gosh, I need glasses. Okay, so I would look at this. I know between these two, I know chlorine. So that's an overall -4 charge, so I know silicon's +4. Then I know oxygen is -2. I know hydrogen's +1. That balances out, +2, -2. I know chlorine's -1, hydrogen's +1, so not too much work there. I know oxygen is -2, -4, so silicon is +4. So if I look at everything, nothing's changing. Silicon is +4 here, it's +4 over here. Nothing is changing. Hydrogen, +1, +1, -2, -2, -1, -1. This is not a redox. It's a reaction, it's just not a redox. So in order to classify them, there has to be some change of the electrons, because that's what we're trying to do. That make sense? Okay. All right, then letter D. D is a reduction. It's a redox. Okay, so let's figure that one out. Okay, so your signs that you should have had. So any questions how I got those? Did you verify that? Okay, now what's my next step? What should I do? Bracket. Bracket the ones that are changing. Okay, so I can see that my silicon is going from +4 to 0. Do I need to worry about chlorine at all? Nope, it's not changing, so I'm not going to bracket that one. Magnesium's going from 0 to +2. Okay, so take a look at my silicon. It's going from +4 to 0. Is that going to be a loss or gain of electrons? +4 to 0 is gaining. So we have GR, so what's that half? Reduction. Here I have 0 to +2. That's a loss, right? So that's going to be oxidation. To get really good at signing these half reactions, because you're going to need that in the next step. Okay, so we have our reduction. So if this is my reduction half, what is silicon tetrachloride doing? Okay, this is my oxidation agent. And how about magnesium? This is going to be my reducing agent. So this is what you're going to see on your quiz tomorrow. All three of them I gave you are oxidation ones. They're not ones that you have to say there's no redox. So you have three of them. This is what you're going to do. Sign the charges, do your half reactions, and tell me which one's the oxidizing agent and the reducing agent. Okay? All right, look at your charges for E.